Welcome to a lesson with Dr. Powell. Let's take a look at how we can decide how many subintervals we should use to get within a certain accuracy if we're using Simpson's rule. Now, when we use Simpson's rule, at least here, we're going to assume that we're going to use a weighted averaging of the trapezoid rule and the midpoint rule. And the n value that we're going to be using is actually the n that happens for the trapezoid and the midpoint rule in this weighted averaging. Now, if we were just doing Simpson's rule in a standard way, done without a weighted averaging, but just like with different intervals split up. So this midpoint versus trapezoid actually doubles the number of subintervals in that case. And so you would be thinking of a 2n, and this constant would change to 180. But in our case, if we're using a weighted averaging, this constant is 2880 in that particular case, if that is our choice of n. All right, so now looking at this, we want to compute the bound, an upper bound for the error in terms of n, and then we want to set that upper bound less than or equal to 10 to the negative 6, and then figure out what n should be. So let's talk about how we actually get this bound. So in the bound formula, we have an m times a v minus a to the fifth, n to the fourth, and then have a 2880 here. So b and a are just 1 and 2 here, so we can see how to get that. And we're going to be trying to find m. What is that? That's a bound on the fourth derivative of this function in here. So we take the derivatives of this. F is that. We take derivatives, we get down here. This is the fourth derivative. How big can it be? Well, this is a decreasing function on the interval from 1 to 2. So it's decreasing, so it's largest at the left end, and left end is 1. So we stick in x equals 1 into the fourth derivative, and we end up getting 120, and we can use that for our m. So m is 120. Okay, so we run this through. We reduce this by dividing top and bottom by 10. Then we can divide top and bottom by 12, and we get 1 over 24 n to the fourth. We want that to be less than 1 over 10 to the sixth. Reverse inequalities when we take reciprocals, and then we can divide by 24 and take an fourth root, which for positive numbers is increasing. And we end up getting that this value right here is a little bit bigger than 14, but less than 15. So that means that if we just, the number of subintervals have to be at least 15 for this accuracy to work, at least in the case when we're using this weighted averaging. In the other, well, you just double that to 30 if you wanted to use the other method. However, just with this weighted averaging technique, simply use an n value of 15, and that will guarantee an accuracy less than 10 to the or within 10 to the negative 6 of the actual when we are computing this integral via Simpson's rule. Thanks for watching.